Earth hangs in space like a small blue bead. It follows a graceful, predictable path around its star, the Sun. This orbit has remained stable for billions of years, a constant rhythm in the vast silence of the cosmos. Our Sun, in turn, is just one of hundreds of billions of stars, all circling the massive heart of our Milky Way galaxy. The galaxy itself drifts within a local group, a small gathering of celestial islands in an immeasurably large universe. This is our home. It is a place of relative calm and order. Imagine a rogue black hole wandering silently through the galaxy, its path destined to intersect with our own solar system. At first, its presence would be undetectable. From our vantage point on Earth, the sky would look unchanged. The constellations would hold their familiar shapes. The seasons would continue their steady march. But astronomers with their powerful telescopes and precise measurements would notice something amiss. The orbits of the outer planets would begin to show tiny deviations, Neptune, Uranus. A mysterious, unseen mass would be tugging at the very edges of our solar system, its influence growing with each passing year. As the black hole drew nearer, its gravitational pull would become undeniable. The gentle dance of our solar system would be thrown into chaos. As Earth continued its plunge, the first truly noticeable effects would begin. The black hole's gravity would not pull on the planet uniformly. The side of Earth facing the black hole would feel a significantly stronger pull than the side facing away. This difference in gravitational force across an object is known as a tidal force. We are familiar with tides on Earth, caused by the gentle gravitational tug of the Moon the Sun, which cause our oceans to bulge by a few feet. But the tidal forces near a black hole are of a completely different magnitude. They are forces of immense destruction. The initial effect would be seen in our oceans. The water on the side of the planet nearest the black hole would be pulled into a colossal bulge, a permanent, towering tide far greater than any tsunami ever witnessed. On the opposite side of the planet, the water would also bulge outward as the solid Earth was pulled away from it. The world's oceans would be drawn into two massive opposing tidal lobes, near lobe-far lobe. Vast expanses of the ocean floor, hidden for millions of years, would be exposed to the sky as the water was reshaped by this extreme gravitational gradient. This stretching force would not be limited to the water. The solid Earth itself would begin to deform. The planet's crust, which we think of as rigid and unyielding, would start to stretch and crack under the strain. Enormous fissures, miles deep, would open across the continents. Earthquakes of unprecedented scale would rock the globe constantly, not isolated events, but a continuous, planet-wide tremor. The very ground beneath our feet would become unstable, groaning and shifting as the relentless pull tried to tear the world apart. Mountains would crumble, entire land masses would begin to fracture. The atmosphere would also be affected. Pulled by the same tidal forces, the air would begin to flow toward the near side and toward the far side. This would generate winds of unimaginable speed, far surpassing any hurricane. The atmosphere itself would start to be siphoned off the planet, drawn away by the black hole's immense gravity. As the remnants of Earth spiral closer to the black hole, one of the most mysterious phenomena in the universe would come into play. According to Albert Einstein's theory of general relativity, gravity is not just a force. It is a curvature of space-time itself. Massive objects warp the fabric of space-time around them. The stronger the gravity, the more extreme the warp. One of the consequences of this is that time itself is affected by gravity. Clocks in a strong gravitational field tick more slowly than clocks in a weaker one. This effect is known as gravitational time dilation. For a hypothetical observer watching Earth's demise from a safe distance, this slowing of time would become dramatically apparent. As the stream of matter that was once our planet approached the black hole's edge, it would appear to slow down. The light from the glowing plasma would become redder, its wavelength stretched by the intense gravity in a process called gravitational redshift. The final, brilliant flash of light would seem to dim and fade, stretched out over an increasingly long period. They would appear to slow to a stop, hovering just at the boundary, frozen in time for all eternity. The final boundary is the event horizon. It is not a wall or a membrane. It is an invisible threshold in space-time. It is the surface around the black hole where the gravitational pull becomes so strong that the escape velocity exceeds the speed of light. Nothing that crosses this line can ever get back out. No information, no light, no signal of any kind can escape to the outside universe. It is the ultimate point of no return. Once the stream of matter that was Earth crosses this boundary, it is causally disconnected from the rest of the cosmos forever. The journey ends at the singularity. This is the heart of the black hole crushed into zero volume and infinite density. At the singularity, the known laws of physics break down completely. As the remnants of Earth reach this destination, matter as we know it ceases to exist. Earth's mass is added to the black hole. The black hole grows slightly, its event horizon expanding by an infinitesimal amount. The story of Earth's fall into a black hole is a thought experiment, an exercise in cosmic imagination. The odds of this ever happening are vanishingly small. Yet following this journey from a calm orbit to a final violent end teaches us something profound. Black hole research helps us probe gravity, space-time, and the universe's limits. It stresses the overwhelming power of gravity, shaping cosmic structures and defining the boundaries of physical laws. We are temporary residents in a vast, powerful place. Reflective. What is our responsibility to this delicate island of life, adrift in the great cosmic sea?